Have you ever wondered about the fundamental principles that govern our physical universe? Let us delve into the mind of Sir Isaac Newton, the man who did just that in his monumental work, Philosophiae Naturalis Principia Mathematica, or Principia, published in 1687. This revolutionary work shifted the paradigms of our understanding of the physical universe. The Principia, split into 3 books, is a treasure trove of scientific thought. The first book introduces Newton's 3 laws of motion, the bedrock of classical mechanics, laying the groundwork for understanding how objects move under the influence of forces. In the second book, Newton plunges into the world of fluid dynamics, exploring the behavior of objects moving through fluids. He then takes us to the stars in the third book, weaving his laws of motion and gravitation into the fabric of celestial mechanics. As we journey through these 3 books, we will uncover the pillars of classical mechanics, fluid dynamics, and celestial mechanics. Scene script. Book 1 of Newton's Principia is where we find the foundation of classical mechanics, defined by Newton's 3 laws of motion. Diving right into these laws, the first one states, an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Think of it as the law of inertia. It tells us that objects like to keep doing what they're doing, whether that's moving or staying put. Moving to the second law, it's all about force equals mass times acceleration. This law links the concept of force with the amount of stuff or mass an object has, and how that stuff is accelerating. The more mass an object has, the more force you'll need to change its speed or direction. Lastly, we have the third law. It's the one you've probably heard before. For every action there is an equal and opposite reaction. When you push against a wall, the wall pushes back with equal force. These 3 laws of motion create a comprehensive picture of how objects move under the influence of forces. They allow us to predict an object's motion given its initial conditions and the forces acting on it. These laws not only define motion but also introduce the concepts of force and mass, creating a robust framework for understanding our physical world. Moving on to Book 2 of the Principia, Newton delves into the world of fluid dynamics. Here, he explores resistive forces and the fascinating behavior of objects moving through fluids. Picture this: an apple falling from a tree, a leaf floating down a river, or a bird soaring through the sky. These natural phenomena, seemingly simple, are governed by complex forces at play, and Newton was keen to unravel these mysteries. In Book 2, Newton scrutinizes the forces that resist an object's motion in a fluid environment, such as air or water. These resistive forces, he found, are critical for understanding how objects move in such environments. From the gentle drift of a feather to the powerful thrust of a jet engine, the principles laid out in this part of the Principia are fundamental to our understanding of terrestrial motion. But Newton's curiosity extended far beyond the confines of our planet. And so, in Book 3, he takes us on a journey into the realm of celestial mechanics. Here, he applies his laws of motion and gravitation to explain the motions of celestial bodies. Imagine the dance of the planets around the sun, the moon circling the earth, or a comet streaking through the night sky. All these celestial ballets, Newton discovered, are choreographed by the same laws that govern motion here on Earth. This unification of terrestrial and celestial mechanics is a profound achievement. It signaled a shift in our understanding of the universe, demonstrating that the laws governing the physical world are universal, applying equally to an apple falling from a tree and the moon orbiting the Earth. By applying the same laws that govern objects on Earth to the heavens, Newton demonstrated the universality of these principles, a profound achievement. His work on fluid dynamics and celestial mechanics, as detailed in the Principia, forever changed our understanding of the physical world and our place within it. One cannot discuss the Principia without acknowledging its mathematical rigor. Newton's genius extended beyond physics. He developed calculus, a sophisticated mathematical tool, to precisely express his laws and equations. This not only made the Principia a landmark in physics, but also in mathematics. Newton's work bridges these 2 disciplines, showcasing the power of numbers to explain natural phenomena. Newton's Principia, with its insights into motion, gravity, and fluid dynamics, remains a cornerstone of scientific thought, forever changing our understanding of the physical world and our place within it.